Hello everyone, welcome back to my YouTube channel. So today we'll be solving a LeetCode problem which is based on binary search, and it's easy level problem but very important to understand the concept of binary search because a little modified version of binary search you can say that. So let's first try to understand the problem and then we will code it. So this is our problem. It says first bad version. Now let us understand what this means by a bad version. So it says you are a product manager currently leading a team to develop new product. Unfortunately, the latest version of your product fails the quality check. Okay. Since each version is developed based on the previous version, this is the line to be considered. उसने कहा कि next version कैसा होगा depends totally upon the previous version. So if I just mention here कि these two versions are good, then the next version also be good. Now, due to some problem, some disparity and some problem here, I have another version which is bad. So the next version will always become bad only. Okay. So now if we see here, suppose you have n versions 1 to n and you want to find out the first bad version which cause all the following ones to be bad. तो हमें उस bad version को ढूंढना है. You are given an API bool is bad version, which is already present in our function. You can say this will return us true or false based on whether our given version is bad or not. So we have to implement this function which calculates the first bad version. So if you relate this problem with binary search, what binary search used to do is it used to search in a sorted space. Let's say these numbers are sorted. So if I have to find a number, a target, so I will use binary search in this case if my numbers are sorted. Similarly, here if you don't consider numbers, let us consider G and B for good and bad. So if a sample is good, let me mark it as G, and if a sample is bad, let me mark it as bad. Okay. So now, if you're aware of binary search, what we used to do is we used to first calculate the middle value, check the middle value. If it is equals to target, so we used to return that pointer that yes, this is the point where my value is present. But in case the value is not present, so we used to check whether it is greater than target or it is less than target. If my value, let's say, is less than target, in that case, what does it means? Ki my target value will always be after the mid. Okay. And if my target value is greater than, oh sorry, mid value is greater than the target value, what does it means? That target will always be on the left side. So this is how we used to shift the pointers in case of the normal binary search approach. But here we have to modify it, and what modification we have to do is we will check. We'll here also calculate the middle. We'll call our is bad version API. If it returns true, in that case, what will happen that yes, this is a bad version. But of course, there is a possibility that on its left side we have another bad version. So we have to find the first bad version. So that's why what I will do is I will store this answer, move my pointers to the left side to check for another bad version. Just in case, let us take the second case. Second case is this is a good version. If it is a good version, it means that the left side all are good versions only. So what I will do is I will move my pointer to the right side in that case if I notice a good version. So we can also see this example here. It says you have input n equals to 5 and 4 is the bad version, which is quite similar to this example which I have taken here. Okay, if it's a bad version, what will happen is pointer will shift to the right, then we will discard the left part, and now we will calculate the mid from the remaining part of the array. And this is the array. So now if I calculate here, and this will become my answer. Okay, because I've got the bad version, so I will return the first bad version as 4. Now let's go through the code. So as we do in binary search, we are taking a left pointer, we are taking a right pointer. We are not decrementing here because this is not an array that we have to keep the index track, but we have to, like search for every element from 1 to n. We have to include n here. That's why here -1 is not done. Okay, it is not required here. Next, we have calculated answer, which will hold our first bad version here. Okay. Okay, let's just write here that it will store our bad version. Now moving our pointers as we do in binary search, we'll move from left to right. The first thing we will do is we'll calculate the mid, and this is a way to calculate middle value only, and it optimizes our code. So that's why we use this. We can also use left plus right by 2, which is also give us the middle value. Okay. Now I'm doing here is I'm checking is the middle value the bad version. If it's bad version, let's store it in the answer. And if it is a bad version, there is a possibility that there are more bad versions to the left side. So I will move my pointer to the left side. Otherwise, what I can do is if it's a good version, that let's move the pointer from mid plus one, which means that if it is a good version on the left side, they are all good versions only. So I don't need not to check there. As we can see in example, if it's a good version, then other values are all always will be a good version to the left side. So we will move our pointer to the mid plus one. Okay. And if we move our pointer to mid plus one, we will not take this value. Okay. It will be BB and we'll get our first bad version from here. So at last, after traversing the whole like range from 1 to n, we'll return our answer. So this is how it will work. And the same code I have written here also. Let's try to run this code. So as you can see, it is passing the test cases given here and producing correct output. Let's just submit this to test for the rest of the test cases also. So it is accepted and its runtime complexity will be log n because we are using binary search and we are reducing the search space by 2 every time. So yeah, that's all for this video. I hope this video solution was clear to you. If you have any doubt, leave it in the comment section. Like, share video with your friends who are just preparing DSA or just started with that. And yeah, keep learning, keep coding. Bye bye.